Hi, I'm Dr. Robert Harris. I'm a researcher with Georgia Tech Research Institute. Right now I'm working with photonic integrated circuits and creating chips that write DNA for computer memory. I'm here at the Computer Museum of America, which has the world's largest collection of supercomputers. This is the Cray 1, which is also in the Smithsonian, and Washington, D.C. It holds a very important part in history. So what is a supercomputer versus a cloud, for example? Or what is a supercomputer? Supercomputer is the top of the highest performance of computing. It can access a tremendous amount of data and go through it very quickly. They're built for different purposes and different problems. People are interested in cloud computing. Cloud computing means a computer you can't see. It's abstracted. You're sending your data away. But somewhere there's always hardware sitting in a building, a data center, and it could potentially have a supercomputer to crunch your data. So what are supercomputers used for? The focus has shifted over the years. Originally they were used for a lot of environmental simulations, weather simulation, nuclear experiments once banning of nuclear detonations went into effect. And over time they've been used to design aircraft, electronics, and now there's a lot of interest on looking at data that people are producing, looking for patterns, finding trends, statistical analysis, and looking for new materials. For example, new materials that could produce lighter, more powerful batteries. So what industries are they used in? I would say in a lot of anywhere where people are designing materials, engineering applications, 3D modeling. Supercomputers are a tool in the toolbox, and they could be used by a lot of different people. For example, programmers, statisticians, and designers, and there could be a whole team to help you solve your problems. So if you want to work with supercomputers, I think computer science is a great background. According to Wikipedia, the first supercomputer was a UNIVAC, and pretty soon thereafter, Seymour Cray is the father of the supercomputer, and he left his company, which was SMC, to form Cray Research, to build the Cray 1. A lot of the original applications of the supercomputers were for the military and tracking artillery and trajectory of artilleries that could be launched and under different conditions or wind conditions, or even drop from airplanes at different velocities, speeds, wind conditions, and different weights of payload. So goes back to Isaac Newton and a lot of the work he did, also for military purpose. Seymour Cray, who we think of as the father of the supercomputer, left the CDC Corporation to form Cray Research and created this Cray 1. And this one came from the Max Planck Institute in Germany.
Hello, I'm Lonnie Mims, founder of the Computer Museum of America, where we are today.
Hi, I'm Robert Harris. Lonnie, tell me, how did you get interested in and started in collecting supercomputers?
Well, I really started with micros, which were the machines that I was most interested in growing up as a child. But I came across a Cray 1A probably about 10 years ago and traded an Apple I board for it. And that just was to me the coolest machine I had ever seen. And supercomputers were something that was not anything people would even see if they were using them. And even today, I think most people that are using supercomputers never actually see them. So to be able to obtain one was just beyond my wildest dream.
So before you mentioned that the definition of a supercomputer is like a moving target through time. How does that work?
Well, at any moment in time, people love to come in here and go, well, my phone is more powerful than all these machines. And for the most part, that's true. But your phone can probably do about 10 to the 12th calculations or operations per second. And When you get into the early 2000s, the supercomputers that we have in the museum here are quite a bit faster than that. But getting back to the question, at any moment in time, your phone in your pocket would have been a supercomputer. And it's a pretty loose definition, but I generally think of it as being the fastest machines in any given time period. And usually they're several orders of magnitude faster than your average computer during that particular day and age. The fastest machines now can do more calculations in a second than you could do in about 7 billion years if you did one calculation per second. So it's very hard to understand the speed of these devices.
So I'll tell you, one of the things that's so amazing to me to be able to come and see these is thinking about the history. To me, it's very interesting to see where everything came from, what was the start, how did we get to be where we are now. And there's a point in time where things aren't valued and they throw away. Let's say like Victorian houses, they were tearing down left and right at some point in time. And now they're very rare, and you can go take a tour of one and pay 20 bucks to go take a tour of a nice era Victorian home. At some point in time, something super mundane like a telephone answering machine will be, like in 50 years, will be super rare and will be in a museum and people will marvel over the mechanical tape that wound through. These were never mundane. These were never everyday items. These were really expensive and rare to begin with. And now, all these years later, what is the significance of having these here?
Well, it is amazing though, even though they're rare, that once they become obsolete and they cost more to run, they're huge power consumers. When they cost more to run than what they're actually producing compared to more modern equipment, they typically get recycled because again, they're too expensive for anybody to use them to run. It's not like a hand-me-down PC. There's a definite economy involved with that, and these old machines have a tremendous amount of rare metals in them, and items that are more valuable at a certain moment in time as a recycle. We have one Cray board here that has over 3 ounces of gold in it, and there were multiple boards within that given computer. So you start looking at, once it becomes just salvage, there's thousands of dollars worth of gold in a machine, and they did that because it was, the best conductivity relative to, not oxidizing. There's no corrosion with gold, things like that. So the machines have been disappearing, and more recently, the problem is that supercomputers typically are located in either high security facilities or they're located in colleges, and the ones that are located in government high security facilities, they're literally afraid for those to go out and go into museums or go into private hands because there might be some data that's somehow is stored in them somewhere, even if they take all the hard drives out. And just as a matter of the bureaucracy, by default, they go from where they're operating with a certified carrier to a certified recycler, and they get completely destroyed at the end of the day. So we don't have some of the history that and that's one of the goals we have here, is to preserve these machines when we come across them.
So not only that, I have to respect how difficult it is to acquire them. Not only any that were used in a classified sense, but they were owned by the government. So nobody after work, they're done with the computer. No one can say, "Oh, I'll take it home." It's a waste computer. It has to be destroyed or gone out to auction and resold. And an individual is very unlikely to end up with equipment like this.
That's true. And the other factor is weight.
Right.
The heaviest machine we have here, which is not even as large as a typical automobile, is 26,000 pounds. So you can imagine trying to get that. You don't put that in the back of your pickup truck and then stick it in your garage. It was a pretty extensive process to get all of these machines delivered and installed into this facility, and we're on a 6-inch slab here, so that we don't have to worry about it falling through the second floor of the museum.
How did you get this, and what's the story of the Pixar computer?
Well, we obtained this particular machine out of a gentleman who owned it in New Mexico, and there's are some connections to the machine with New Mexico and some of the folks that actually created it. But back when George Lucas was filming Star Wars, he had a lot of different issues to try to create all of the extensive graphics and the big scenes that are in the early Star Wars movies. So he wanted to find a better way to do that. So he created a graphics division within his company to be able to make some of the background scenes and some of the animations that go into the standard movies a little bit easier. He hired some folks out of a college in New York that was doing the early graphics work, and came up with some of the very first CGI, first computer generated images. And out of all of that, they decided that they needed a fast machine to be able to render these graphics. And that was where the Pixar computer was born. So Pixar originally started out as a machine. So this is the second version of the Pixar computer. They didn't sell too many of these, and it was mostly to the medical industry for looking at X-rays and things like that, and analyzing medical data. So they only used it for, I think, a couple of the shorts that were made at Pixar originally. And when George Lucas was going through a divorce in I think 1983, he started looking at some of the extra the assets that were really weighing in on him. And at the point that this machine was created, I think his royalties were going down at Star Wars, and he just decided this was just a lot of cash flow that was going out, and there wasn't a whole lot of market. And they managed to, he was introduced to Steve Jobs. And Steve Jobs looked at the company and thought, this is pretty cool. And there are some amazing folks that were working at the company at the time. And once Steve Jobs took over the ownership, I think he paid $10 million for this division from George Lucas. He was still feeding it quite a bit of money every year, but they came up with the idea that we could actually make our own movies because the hardware wasn't selling. There just wasn't a market for a very expensive graphics calculator, is what it amounts to. It's almost like a version of the graphics card that would be in your computer today. It still needed another computer on the front end of it, which typically was a Sun workstation, to feed it the data and then pull the data back out into a more usable output. So they figured out that if they worked with Disney as their marketing company, and Jobs was just brilliant in his relationships and the deals that he could work out, he came to an agreement with Disney to market the film. And they made Toy Story. There's a lot more nuances behind it, but at the end of the day, they made Toy Story. And as the years went by, he worked better deals with Disney, and ultimately sold the entire company to Disney, and was their largest shareholder whenever he passed away a few years ago.
So Lonnie, you were just explaining to me that early on, the early supercomputers stood monolithically by themselves, and they had really cool designs externally to reflect the value and the amount of work that went into them. And now the machines are racks and racks of servers and rows, so they have to put a little bit of detail and design into the outside of them.
Yeah, it's hard to know exactly when it happened, but when you come to the museum, you'll see that around the early 2000s. And it's not that you'd have a Cray 1A just sitting by itself. There was a tremendous amount of support machinery that would go around it. You'd have the separate hard drives, and you had all of the different workstations that would access it, and tape drives, things like that. You know, big, massive washing machine size disk drives. But now it's almost like we've made full circle again, where in the early days, you can picture the IBM 360, and it would take a whole room full of machines, and you'd have rows and rows of big freezer size, refrigerator size equipment that would have tape drives in them, you know, with the circles. That was what I always drew as a kid as a computer. It was actually the tape drive. And now we're back to that, where it's a whole room full of machines, whole room full of equipment, and you can see all the wiring that goes into connecting them all together, and you know, just an amazing amount of power and noise if you go into one of these rooms.
Good, yeah, and we should also recognize the amount of chilled water being piped through here.
Yeah, cooling has always been a problem with the supercomputing. That anytime that you're pumping in a lot of power and you know, a lot of energy, only a portion of that is going into the actual computing. It's almost like an incandescent light bulb, where you get a certain amount of light, but then you're getting a lot of heat out, and that made the Easy Bake Oven possible.
And there's a list of the top supercomputers in the world called Top 500. Is that
Yes.
the website?
Yes. And that's updated on a regular basis. And the machine behind us, which this is a mural, is located in Oak Ridge, Tennessee. And up until just a few months ago, which would be, you know, somewhere around June of 2020, that this was the fastest machine in the world. And now it has been supplanted. It's number 2 to a machine in Japan. So Japan now is back on top of the list. It was a battle between kind of the US and China as to who was going to have bragging rights for that fastest machine. But years and years ago, it was between the US and Japan. So China's a fairly recent player in that 500 list.
What are the chances they just add another row and then catch up?
That could always happen, and there's always that chance that you know, that there's several machines in the world that are tremendously faster than anything on the list, and we just don't know about it. They might be in Area 51. And we would love for you to come visit us in Roswell, Georgia. And again, that's the Computer Museum of America. Thank you.